Hi, in this video I'd like to show you the effect of distortion loss. This loss is proposed in Mip-NeRF 360 and its effect is to encourage the weight distribution to be concentrated. An explanatory figure is like this. So this is the weight distribution. The x-axis is the sample distance and the y-axis is the weight. So before applying the distortion loss, you can see that the distribution is like the gray part, so it's not concentrated, it has multiple peaks like these three. And after applying the distortion loss, it encourages the weight. So you can see that the orange arrow, it encourages the weight around the peak to be greater, so the weight to be concentrated. And you can see the blue arrows, it encourages the samples to be concentrated around the peak. So after applying this loss, we expect the distribution to be concentrated. So in the paper it says that so it can avoid background collapse where the background is stick to the camera. And another big benefit is that it encourages the cloud. So if you have experience in training, for example, instant-ngp, you will notice that, so I'm now training the Fox scene, you will notice that there is a huge amount of this cloud behind the actual scene. And this cloud actually doesn't contribute much to the rendering. For example, I can reduce the rendering box size. For example, I can reduce this X range, and you can see that the rendering doesn't change much, meaning that this part is actually useless. So you can remove this and the rendering doesn't change. And for example, you can remove this Y range too, Z range too, and the rendering doesn't change either, meaning that all these parts, all these clouds are actually meaningless. So why do we have them? It's because in volume rendering it tries to maximize the reconstruction, so it adds these random clouds to match the actual observation, but it actually only adds very little amount to the PSNR, for example 0.1, 0.2. But in order to add that 0.1, 0.2 points, it produces a lot of these random clouds, which is not what we want always. So in order to reduce this cloud, we can apply the distortion loss proposed in this paper to make the distribution concentrated. For example, so in the Fox scene that we just showed, there's actually a wall here. We don't expect the wall to be that thick, right? We expect the wall to be very thin wall, just like few centimeters around this actual position, not all these clouds. So I implemented this loss in my ngp in PyTorch Lightning, and I trained these two scenes, and now I can show you the difference. First is the scene trained with the original loss, so only the reconstruction loss. So you can see that in my implementation there is also a huge amount of cloud behind the actual wall. So this is Fox and there's a wall behind it, and there is a lot of random clouds behind the wall. So yeah, this is the training with original loss, and now I can show you the result after adding the distortion loss. Now you can see that the huge amount of cloud behind the wall is actually largely reduced. So now we only have a tiny amount of cloud and the wall is very tight, like this. So how does this help in reality? You can notice that the samples per array here now is very small compared to where we have a huge amount of cloud, right? So in this setting, because the cloud is reduced, so the volume rendering can now only allocate a very few number of samples to actually render the scene, and the scene representation is much more compact than before. So this is one advantage. But you can also notice that there is some random noise appearing here in front of the scene, which is not the case when we didn't apply distortion loss. This is one drawback. Now I can show you another scene that I trained with and without distortion loss. So in this example, I want to focus on the samples per array in volume rendering. So this is the garden scene in Mip-NeRF 360. So you can look at the samples per array. In this sample is 24 or 25 before applying distortion loss. So you can see that the rendering speed is quite slow. It's like 200 milliseconds. And if I move the cursor, the scene takes some amount of time to render. Okay, now let's switch to the result after applying distortion loss. Right. Okay, so in this case, you can notice that the samples per array now is only around 10 compared to 25 before. So it has a 2.5 times speed up. So now the rendering speed is much faster. It takes just around 100 milliseconds, and the manipulation here is much more smooth, right? So this distortion loss actually reduces that huge amount of cloud and improves rendering speed, and the rendering quality only reduces a little. So I think this loss is, yeah, a very good benefit if you want to apply NeRF in real-time rendering to increase the speed and to improve the model representation compactness, right? Alright, so that's all about today's video. Thank you very much.